open with a crack that rattles windows and sends people outside to look up. For most of human aviation history, Mach 1 was the barrier, the wall, the speed that engineers spent decades trying to reach, and that, when it was finally broken in October of 1947 by Chuck Yeager in a rocket-powered aircraft over the California desert, felt like the edge of what was physically possible for a machine carrying a human being. The Orion capsule named Integrity hit the Earth's atmosphere on April 10th, 2026 at Mach 32. Not Mach 2, which is twice the speed of sound and the domain of supersonic jets that require specialized airframes and exotic fuel. Not Mach 5, which is the threshold of hypersonic flight and requires materials that most manufacturing processes cannot reliably produce. Mach 32, 32 times the speed of sound, a number so far beyond the scale of anything the word fast was built to describe that the comparison to Chuck Yeager's record-breaking flight feels almost insulting to both ends of the comparison. Yeager broke the sound barrier in a vehicle traveling at 767 miles per hour. Integrity was traveling at 25,000 miles per hour. The ratio between those two speeds is approximately the same as the ratio between a person walking and a commercial jet. And inside Integrity, 4 people were still breathing. This is the story of what Mach 32 actually is, not as a number in a mission summary, as a physical event, as a set of forces and temperatures and pressures and failure modes that the human body was not designed to survive, and that 4 members of the Artemis II crew survived anyway, for reasons that are specific and engineered, and that came within measurable distance of not being enough. The Mach scale is a ratio. Mach 1 is the speed of sound in the medium the object is traveling through. The speed of sound is not a fixed number. It changes with temperature and pressure and the composition of the medium. In the thin, cold upper atmosphere where the Orion capsule first contacted discernible air on its return from the moon, the speed of sound was lower than it is at sea level, which means that Mach 32 at that altitude corresponds to a slightly different absolute velocity than Mach 32 at sea level. But the physics of what happens at those speeds is not sensitive to the distinction. At Mach 32, the medium through which you are traveling does not behave like a medium anymore. It behaves like a wall. Air is made of molecules. Nitrogen, oxygen, trace amounts of other gases, all of them moving in random thermal motion, colliding with each other and with anything that passes through them. At normal speeds, those molecules have time to react to an approaching object. They receive advance notice in the form of pressure waves that propagate at the speed of sound ahead of the object, and they begin moving out of the way before the object arrives. This is why objects can move through air at all. The air cooperates, the molecules step aside. But here's the problem. At Mach 32, the object is moving faster than the pressure waves that would give the air molecules their advance notice. The air has no warning. One instant, the space ahead of Integrity was empty atmosphere. The next instant, the capsule was there, moving through those molecules at a speed they could not react to, compressing them against each other with a violence that the word compression does not adequately contain. The molecules had no path of escape. They stacked up in front of the oncoming vehicle in a bow shock, a standing wave of compressed, overheated gas that formed within microseconds of first atmospheric contact, and that concentrated the kinetic energy of 25,000 miles per hour into a region of superheated matter that stands a few feet ahead of the heat shield and wraps around the capsule like an atmosphere made of something the universe reserves for the interiors of stars. The temperature in that bow shock at peak heating reached approximately 18,000 degrees Fahrenheit. The surface of the sun is 10,000 degrees Fahrenheit. The air around Integrity at Mach 32 was nearly twice the temperature of the visible surface of the nearest star. Not the core of the sun, which reaches 15 million degrees and requires nuclear fusion to maintain. The surface. The part you can see with the right equipment from Earth, the temperature that, if you were standing on it, would vaporize every atom of your body faster than the nervous system can generate the signal for pain. The air around Integrity was nearly twice that temperature, and this is where things change. At 18,000 degrees Fahrenheit, air stops being air. The thermal energy is sufficient to strip the electrons completely away from the atoms that compose it. Nitrogen and oxygen, the molecules that you are breathing right now in their familiar, benign, life-sustaining configuration, become a cloud of stripped nuclei and free electrons moving at velocities that make the word fast meaningless as a descriptor. This state of matter has a name. It is called plasma, the fourth state of matter, after solid and liquid and gas, the state that makes up the interior of stars and the bolt of a lightning strike. And for 8 minutes on the morning of April 10th, 2026, the environment immediately surrounding 4 living human beings traveling at Mach 32 over the Pacific Ocean. Plasma does not conduct radio waves the way air does. It absorbs them, it scatters them. The electromagnetic frequencies that NASA's Deep Space Network uses to communicate with spacecraft cannot propagate through dense, hot plasma with the fidelity required for data transmission, which means that the moment Integrity entered the peak and heating phase of its reentry, it became as unreachable as if it had never existed. The screens in mission control went blank at 4:14 in the morning Pacific time. Every data feed, every telemetry channel, every heartbeat monitor tracking the biometrics of 4 astronauts, gone. Not degraded, not intermittent, gone. For 13 minutes, in a room full of the most capable aerospace engineers on Earth, nobody knew whether the people inside that capsule were alive. But it gets worse. The heat generated by Mach 32 is not the only way the speed tries to kill you. The deceleration does its own work on the human body, and the physics of deceleration from 25,000 miles per hour to a parachute survivable velocity are as extreme in their biological implications as the thermal environment is in its engineering ones. The capsule cannot simply stop. There is no mechanism for stopping suddenly in an atmosphere. The deceleration must be managed, spread over time and distance, controlled through the lift characteristics of the capsule's shape as it angles through the atmosphere on a calculated trajectory designed to bleed off velocity at a rate the occupants can survive. The result is a sustained period of G-force loading that pressed into the 4 crew members at peak levels of 4 to 5 times the force of Earth's gravity. At 5G, a person who weighs 180 pounds effectively weighs 900 pounds. The heart, a muscle roughly the size of a closed fist that operates every second of every day to pump blood against normal gravity, must suddenly pump against 5 times normal gravity. Blood is a liquid with mass. Under 5G, it wants to pull in the lowest parts of the body away from the brain. The cardiovascular system fights to prevent this because the brain stops functioning within seconds if its blood supply is interrupted. Every breath requires conscious muscular effort against the weight of a chest that has tripled in effective mass. Moving a hand, lifting an arm, performing any of the monitoring tasks that the crew needed to execute during reentry required deliberate force against a body that effectively weighed 5 times what it weighed on the ground. This is not theoretical. The 4 astronauts of Artemis II experienced this directly, not in a simulator, not in a centrifuge where the session can be stopped, in a capsule traveling at Mach 32, surrounded by plasma 13 minutes into a communication blackout, with a heat shield outside that had already demonstrated on a previous mission that it could fail in ways that the engineering models had not predicted. They sat in their seats under 5G and monitored their instruments and trusted that the people who built the machine around them had gotten the math right. But that's not even the worst part. The heat shield on Integrity had a history. During Artemis I, the uncrewed test flight in December of 2022, the recovered capsule showed heat shield damage at more than 100 locations across its surface. The Avcoat material, the ablative compound specifically designed to char and erode during re-entry and carry the thermal load away from the capsule in the process, had failed in a way that the engineering models had not anticipated. Gases generated inside the material during the heating phase could not vent through the outer char layer. Pressure built. When the outer layer cooled during the skip phase of the re-entry trajectory and then reheated during final descent, the pressure that had built behind it had nowhere to go. It blew out through the char layer, carrying chunks of the ablative material with it, creating gaps in the shield's surface at more than 100 locations. Had the damage been worse? Had the gaps been larger? Had the insulation beneath the ablative layer failed to prevent thermal penetration into the crew compartment, the outcome of Artemis I would not have been a successful splashdown and an engineering investigation. It would have been a tragedy. NASA investigated for 2 years. The investigation identified the root cause as the reformulated Avcoat's reduced permeability compared to the original Apollo-era formulation. The solution was a modified re-entry trajectory that would keep the outer char layer permeable throughout, preventing the pressure buildup that had caused the damage. A new heat shield design was ordered for future missions. The shield already installed on Integrity, identical to the one that had failed on Artemis I, flew as is. The bet was that the trajectory modification addressed the failure mechanism sufficiently. A former NASA astronaut and engineer named Charles Camarda said publicly before launch that the bet was not adequately supported by the available data, that the root cause was not fully understood, that the analysis was insufficient to certify 4 human lives behind a heat shield with a documented failure history. NASA launched anyway, at Mach 32, with the same shield, on a modified trajectory, trusting a 2-year investigation that a credentialed expert said was incomplete. At Mach 32, there is no margin for the kind of uncertainty that Camarda described. The plasma is real and immediate. The temperature is 18,000 degrees Fahrenheit, and it is there right now, outside the capsule, separated from the crew compartment by a layer of material that has demonstrated it can fail. The G-forces are pressing into the crew's chests at 5 times their body weight. The communication blackout is total and will remain total for 13 minutes. If something goes wrong at Mach 32, nobody outside the capsule will know for 13 minutes, and when they know, there will be nothing they can do, because the physics of Mach 32 do not wait for response times. The parachutes opened. The screens in Houston came back to life at 4:27 in the morning Pacific time. The telemetry resumed mid-data, as if nothing had interrupted it, as if 13 minutes had not just passed in a room full of people watching blank screens and watching a clock and knowing that the only thing standing between 4 living people and 18,000 degrees Fahrenheit was a layer of material that had already proved it could fail. The biometrics returned. 4 heartbeats, all elevated, all present. Temperatures nominal, pressure nominal. The heat shield had held. The trajectory modification had worked. The math had been right. The USS John P. Murtha recovered the capsule from the Pacific. The hatch opened. Commander Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen stepped out into the morning air. They were intact. The mission was a success. The word historic was used many times in the press conferences that followed. Photographs were taken. Statements were made about the future of human exploration, about the moon, about Mars, about the next chapter of the species. None of the press conferences used the phrase Mach 32 in the way that phrase deserves to be used, not as an achievement, as a threshold, as the speed at which air transforms into something that kills by existing, and the speed at which everything a human body is made of, every bone and organ and cell and the specific arrangement of molecules that constitutes a living person, becomes a problem that only engineering, and only the specific engineering of a heat shield and a trajectory and a guidance computer and 11 parachutes and a recovery ship positioned exactly where the math said to position it can solve. Mach 1 broke the sound barrier in October of 1947. A human being was inside the aircraft when it happened. Everyone watching knew it might kill him. It did not. He described the moment of passing Mach 1 as almost anticlimactic, smoother than expected, the predicted turbulence less dramatic than feared. The barrier, once crossed, turned out to be less of a wall than the name implied. Mach 32 is not a barrier. It is not a threshold with a smooth crossing on the other side. It is the speed at which the atmosphere of this planet generates temperatures that approach twice the surface of the sun, at which communication with the ground becomes physically impossible, at which the heat shield is the only thing between 4 people, and a death that would occur in less time than it takes for the pain signal to reach the brain. Chuck Yeager broke Mach 1. 4 astronauts survived Mach 32. The distance between those 2 events, measured not in speed but in what the speed does to everything it encounters, is the distance between the edge of what was possible then and the edge of what is possible now. Both edges were defined by the same thing, the maximum that the engineering could hold against the physics, the last number before the number that kills you. The universe set the physics, engineers set the margin, and 4 people trusted the margin at 32 times the speed of sound, in a plasma sheath hotter than the sun, 30 minutes from the nearest human voice, with a heat shield that had already failed once before. The margin held, this time. At Mach 32, this time is the only time that matters.